Hello everyone and welcome back to yet another video. In this video today I will be talking about an overview of the next generation network, or NGN for short. Okay, let's just jump right into the definition. So this is the definition of the next generation network based on the ITU-2 released. But in another word, the next generation network is a collection of significant architectural improvements in telecommunication core and access networks. The fundamental concept behind the NGN is that a single network carries all information and services, such as voice, data, and other media such as video, by encapsulating them in IP packets similar to those used on the internet. Next is the practical perspectives. So in an NGN, there is a more defined separation between the transport portion of the network and the services that run on top of that transport. This means that whenever a provider wants to enable a new service, they can just do so by defining it directly on the surface layer without considering the transport layer, since the transport layer should be able to accommodate what is defined on the surface layer. So these are the principles of NGN. First of all, there is an open architecture. Second of all is the independent provisioning, and lastly is multiplicity. Okay, next up is the NGN fundamental characteristics. So there are some basic characteristics that exist in the next generation network. First of all, it is packet-based transfer, separation of control function, decoupling of service provision, support for a wide range of services, broadband capabilities, generalized mobility, a variety of identification schemes, unified surface characteristic, comfort services, independence of service-related functions, support of multiple last mile technologies, and compliance with regulatory requirements. Next is the surface transformation. So if we try to compare between the previous network and the next generation network in legacy networks, for example, in legacy networks the surfaces are vertically integrated, and there is a requirement for specific infrastructure components used for service delivery. And in next generation network, unlike in legacy network, which is vertically integrated surfaces, in next generation network, the surfaces are horizontal convergence. There is also componentized network function and new paradigm of standard capabilities as service enabling toolkit. New challenge for regulation, the NGN drives competition from lower to surface layers. So in NGN, the surface development has a few key objectives. First of all, the NGN should not be just a voice network. So NGN is a network that can accommodate anything and not just a voice. Second of all is that surface level equal or better than in-circuit switch networks. The surfaces specified in terms of required capabilities, precise surface definitions, are not an objective like in legacy world, unless it is a public interest surfaces. There is also expected supported surfaces in NGN, such as multimedia surfaces, data communication surfaces, PSTN, ISDN, simulation and emulation surfaces, and public interest surfaces. And surface availability is depending upon provider's decision. In multimedia, the surface features expansion includes real-time conversational voice, point-to-point interactive multimedia, collaborative interactive communication, PTT over NGN, content delivery, broadcast surfaces, messaging, location-based surfaces, presence and general notification surfaces, push-based surfaces, hosted and transit surfaces for enterprises, and 3GPP or 3GPP2 OSA-based surfaces. For PSTN, ISDN emulation and simulation, during the transition into the NGN from the legacy network, the network is required to support the legacy terminal equipment such as the PSTN or ISDN phones, the PSTN ISDN-like capabilities, and for the PSTN ISDN emulation, from the end-user perspective, the NGN appears supporting the same types of surfaces offered by the existing PSTN or ISDN. Legacy terminals are unable to continue to use existing telecommunication services while connected to NGN. The PSTN or SDN simulation. The NGN terminals in an NGN network are unable to use the PSTN or SDN-like service capabilities, but legacy terminals with terminal adaptation may be used as well and implemented over IP-based control infrastructure, such as using SIP. Regulatory and legal requirements for public interest services, including emergency telecommunication, including early warning, individual to authority, authority to authority, and authority to individual, support for users with disabilities, lawful interception, service unbundling, number portability, network or service provider selection, prevention of unsolicited bulk telecommunication, malicious communication identification, user identifier presentation, and privacy. NGN should provide capabilities for supporting public interest services required by regulation or laws of international or national administrations. The concept of capabilities as reusable building blocks for services and application. A reusable set of capabilities, functional groups within SP's network, reusable by other services. Interworking of functions for service execution and management may be used by services within SP's network or outside. Support of multiple and future business models. Third-party access, externalization, underlying capabilities versus service creation or execution environment capabilities. This is the how do I say it? This is actually the figure that illustrate the concept of capabilities as reusable building blocks. Okay, next. So these are the NGN capabilities, including transport connectivity, communication modes, media resource management, etc. You can see in this list. Let's just go to the next slide. This is the NGN basic reference model. As you can see, there is a separation between the service layer and the transport layer. We can perceive the service layer as Gojek app and the transport layer as the internet service provider. So for the NGN service layer, the user plan is basically like the application, the Gojek application. It can be something that can be used by the user, whether the user want to order GoFood, Gojek, or GoCar, or anything or any services that is offered by the Gojek app. Whereas on the control plane is how the application actually push the order from the user to the drivers or the corresponding restaurant or any other services that is also offered in the Gojek app. Whereas on the management plan is how the user is actually being charged, whether using GoPay or using cash, and the points to the drivers who took the order, and etc. Whereas on the NGN transport layer, we can perceive it as the Telkomsel or any other internet service provider, but in this case I would say Telkomsel. The user plan is basically the application, the packet data, like the order from the user plan on the surface layer is being transformed into a binary, and that binary is in a form of a packet data, and packet data is actually on the user plane. Whereas on the control plane, on the control plane is how the packet data or the binary information is being transferred between the user and the driver or anything. Basically, it's like the middleman. And whereas the management plan is the part of where the Telkomsel actually charge their customers with credits or money, and etc. This is the key feature of NGN function. This is the functional architecture illustration. As you can see here, there is an application on the very top, and the green one is the surface stratum and the bottom one is the transport stratum. This is an overall NGN architecture. This is actually the same with the previous one. As you can see, we have application, surface, and transport stratum. But this is seen by the surface perspective, and this one is seen by the provider perspective. These are the impacts of NGN architecture. As you can see, from the legacy network on the left is we have different blocks for different surfaces. So for PSTN, Internet, they have their own structure. Whereas when we see the picture on the right, where the surfaces on the left is being transferred into NGN, we can see that voice, internet, video, and or multimedia is actually going into the same block or the managed IP platform, and then going to the same block as well as on the XDSL or optic-based fixed mobile. And they can also be seen on the lower figure. Here we can see that there is more simplicity towards the network in overall. Okay, so now we're talking about the QoS, or the quality of service, security and mobility objectives of QoS and security. So for the QoS objectives, or the quality of service objectives, first of all, there are end-to-end QoS environment for the services offered to end users via QoS coordination across the transport stratum. The NGN will also provide an initial set of requirements, architectures, mechanisms, and guidelines to enable end-to-end QoS. Focus on resource and admission control, including coordination between access and core, as well as between core and other NGN. Next is the security objectives. So the security objectives include NGN identified security requirement specifications based on the application of ITU-T X805 to NGN, addressing the following security dimension: access control, authentication, non-repudiation, data confidentiality, communication security, data integrity, availability, and privacy. Addressing the incremental security features required for secure interconnection with other NGN or existing networks. Next is the objectives of mobility and management. Mobility objectives include mobile user requirements, seamless and transparent mechanism for roaming between network operators, and continual access to tailored services from a variety of environments while using a variety of terminals with varying capabilities. There is also no major new interfaces for mobility are proposed. Existing interfaces will be used, and as well as existing signaling capabilities for all types of mobility is currently defined. Personal mobility will exist where users can register themselves to the services, and terminal mobility will exist within and among networks where terminals can register to their networks. Nomadism, mobility without maintaining service continuity, it should be supported between networks and within a network, and this does not exclude support for mobility with service continuity. Next is the impacts of NGN enabling for convergence. The feature should direct to the convergence. Vision and anytime, anywhere, any surfaces and any devices. FMC and IPTV should be the instantiation. Any information or services offered transport infrastructure like VODSL, TVO mobile, and etc. Convergence classifies into following. First of all is the internal convergence and the external convergence. So for enabling for convergence, as we already discussed before, here we can see in the figure that on the left there is a simple linkage between layers, simple business relationship and simple players, whereas on the right to the NGN, simple linkage between layers with dynamics, diverse and flexible business relationship, and diverse business models and players. This is the illustration for the NGN changing regulation frameworks, as you can see on the from the legacy network into the transport agnostic and the access agnostic. And next is the use cases of NGN broadband convergent networks. So we can see that the use cases can be vary from like VoIP messaging, NIDs, IPTV, and others. There's so many different services that can be used in the NGN broadband convergence network. This is the illustration for the UK simplified network. So the top left is the illustration of the structure of legacy networks, whereas on the bottom right is how the structure of legacy network is transformed into the NGN. And from this transformation, there is a reduction number of nodes, around 30 to 40% of offices are being reduced from the structure. And this is the illustration of the future use of NGN for OTO. This is the how we may use the next generation network for our future use. And that is it for this video. I hope that you guys can take all the information that I explained, and I hope it is also clear for you. I'm sorry if there is a confusion in my explanation, and please like if you like this video and dislike if you dislike this video. And as always, thank you for watching.